right. Well, I think it's 9:42. Let's go ahead and just start out by throwing your name in the chat and what you teach and where you teach. And Bill, I'm going to turn it over to you.
Perfect. So I want to first start by thanking everybody for joining us today. I'll give a little bit of background about myself, and then here in a little bit we'll meet Mike, who's also going to help me present some of this information. So I currently teach high school science up in Arlee, and I've been teaching up there for 10 years now. Chemistry we only offer every other year, so I'm by no means a chemistry teaching expert, as I've taught it for less than half of my teaching career. But I had the opportunity to work with Inspired Classroom and with Mpg Ranch on a pretty awesome project where we're looking at some real world chemistry application, and we wanted to bring that application into your guys' classrooms. Currently, the lesson is tailored a little bit more for 9th to 12th grade, but you could definitely modify it, especially the soil sampling piece, for any age group. And so we'll get a little bit more into that here in a little bit. Excuse me. But then as far as kind of how I got involved with this project, a couple years ago, Inspired Classroom offered an opportunity for teachers to go to Mpg Ranch, which is just outside of Florence, Montana. And I jumped on the opportunity thinking it would be a day to go play outside. And in the meantime, I experienced a pretty awesome facility with very passionate scientists, and Inspired Classroom was very passionate about sending their message out to the world. And through that kind of collaboration, I've had the opportunity to work with them on a couple different projects. And so this is kind of our latest project that we've been working on. One other kind of shameless plug for myself, I've recently finished a website. You can see the link on the bottom right down there that I've been working on that helps explain how to integrate Indian Ed for All into the next generation science standards. So when you're looking at creating new science lessons, it could act as a template for how to do that. And then also there's some lessons that I've created on there that integrate the new science standards with Indian Ed for All, which I think is extremely important. So yeah, so as we get going through this activity, it's really gonna help if you guys have questions to make sure you throw those up in the chat box, and then we'll try to answer them as we go. The lesson is not 100% completed, and so we're gonna be looking for a little bit of feedback as well as we kind of go through different parts of it. But yeah, so thanks for hanging out with us, and we'll get kind of started here. If I can get my computer to behave. So this is kind of the progression we're looking at for the activity today. So the first thing I want to do is introduce you guys to Mpg Ranch and some of the resources that Mpg Ranch has available to the public. And I've got some links set up in this presentation, and I'll show you what a couple of those things will look like. After we kind of go through some background about the ranch, I'm going to have Mike introduce himself and talk a little bit about his career and some specific research that he's been doing with soil pH on the ranch. We thought it was really important when we did this lesson that we focused on the fact that chemistry is a career that our students can have that doesn't involve them sitting in a laboratory. And Mike is a great example of what chemists can do out in the wild. And we think, that it'll be really cool for our students to see Mike working and see how being a chemist doesn't necessarily mean you're with a lab coat sitting in your lab. And then we're actually going to start going through some of the activity. I've got about 4 different little pieces of it that I wanted to share with you guys and have you guys kind of work through as if you were students. And we'll see, kind of get some feedback on those materials, and then just kind of also explain the whole progression of the activity as well. So as we get going, at any point, though, like I said, please stop us and let us know. So this first little bit we're going to do is watch this short little doc about Mpg Ranch and what Mpg Ranch is. So here you go.
Mpg is set up like a biological research station. We're a living laboratory. Mpg Ranch is a privately owned conservation organization located right in the heart of the Bitterroot Valley in Montana. Our mission here is to study the land and its ecology and to hopefully be able to restore the land to be as native species rich as possible and as biodiverse as possible.
So we have quite a few people with graduate degrees, and we do research from looking at microbes in the soil to seeing where elk go across the landscape. We're trying to do a lot of basic and applied research. Educate the community as much as possible about the nature here at this site.
So you have a very positive group of people who are fired up about their science and their thing, and we all get to work together.
Basically, I feel extremely lucky because I get to be a 10-year-old. I get to run around and see these animals and catch these animals, handle them and study them. And so for me, it's really a communion with nature.
I've always been interested in why animals move where they do, what triggers them to up and leave, or what triggers them to come back after maybe disappearing for a few years. All that stuff we're able to glean from these camera traps.
Camera trap technology is a game changer. It is what allows us to get that window into just their natural behavior. And so here we set up a couple game cameras. You can see, I mean, they've been here a little while. We've got some. We are not there. We are not influencing them. They're living their lives, and we get a glimpse into that.
What we've sort of implemented since 2010 is a long-term kind of demographic camera trap study where we've tracked up to 25 individuals a year as they live their lives on the ranch. Everybody's got some basic impressions of bears at first, you know, that they're solitary, they're just kind of these curmudgeonly animals, but we're really privileged here at Mpg to be able to obtain a really intimate view of their lives. I've gotten to see interactions, behaviors that have taken place that the human eyes would just typically never see. They're inquisitive, they're curious. They're so much more social than we give them credit for.
You know, when we see males and females interacting, the males are much bigger. When we see a male interacting with a female in the pond, we can see that it's literally pulling its punches and interacting in a gentle way. It takes imagination and possible empathy for a bear to gauge its behavior based on another bear's behavior and size.
You can really see personalities, you know, that they all have an individual, you know, something or other to them that makes them unique.
That's the eagle. You got the eagle there.
March 4th, golden eagle capture with Rob Stockton, Adam.
Mpg Research Institute from Missoula. They were trapping golden eagles here at Mpg Ranch.
Third year bird. These are some older ones. There's new coming in, and they have 3 molt centers. 1, 2, and then 1 over here.
And it turned out that nearly every golden eagle they caught had elevated levels of lead coursing through its veins. Lead was most likely coming from bullet fragments. And golden eagles, they love to scavenge. They're really good at it, and they can seek out these gut piles and carcasses. And if they ingest any of that lead, they can get sick. That's a continental scale implication, right? If a golden eagle is coming down here and being exposed to lead and then flying it all the way to the Arctic Ocean, that's a big deal. So instead of using a lead bullet, a hunter could use a copper bullet, or it's also called a monolithic bullet. So it's solid copper, so little fragments of metal don't get left behind in an animal after it's been hit. What we have here are 2 bullets in the middle. Both of those are unfired. Right here is a lead bullet, and when it was fired into water jugs, all of these fragments were left behind. On the other side, we have a copper bullet that was fired into water jugs, and it remained one solid mass with no fragmentation.
I was introduced as a young boy to tracking by my father, and that lit me up. And that's ultimately what brought me to track and study mountain lions on the ranch. You can see like toe, toe, toe. And this is clearly how cats move through the landscape. Mountain lions, a remarkable creature. There are a lot of cats in the West, but you never see them. They are a ghost on the landscape. And here comes the mother. Oh, the vocalizations on cats, they're like nothing I'd expect. Female mountain lions talking to their young, they just sound like some kind of a bird. We've been following the population as a whole for 7 years. And so we have a rather extensive family tree worked out at this point. Every time I think I know what's going on with the cats on the landscape, they throw me a curveball. I get all the data back, and I feel like I can sit back and say, I know what's happening. Then a mom with 6 kittens goes by a camera, and I'm like, I have no idea what's going on out there. The average litter size for mountain lions is 1 to 4. The average survival rate is 1 to 2. So the fact that she is successfully raising 6 individuals, it's just remarkable. How often do people have the opportunity to witness this? And we capture it all. Kittens playing at kill sites, like just all this behavior that you'd never see. And within what a cat experience is, there are individuals. They behave differently. One may choose to follow her mother for several years. Why, I do not know. Others may disperse immediately. They're making their own choices out there.
Coming out and netting bees is like a full body experience. You have to be looking and you have to be listening.
Okay, so here's a leaf cutter and it's a female, and you can see she's got pollen on the underside of her abdomen.
When we first started the survey, there had been no real surveys of bees in Montana. We collected and identified over 235 species. Really goes to show how little research has been done on bees in Montana.
All of our research is available online. You can ask any of our researchers about whatever you want. And I like that. I like that we're not like trying to bottle some piece of information that we're gonna then sell. The health and success of one species is so interconnected with everything else. And so we're learning the complexity of the web that exists at MPG. And so having all of us working together, able to talk to each other, it makes that research possible, and it makes it much richer.
These animals that I work with are the key for incubating conservation among young people. Kids can go out and see a snake and catch a snake for the first time and look at it, study it, and really kind of connect with it. If we connect with these animals, we'll see their intrinsic value. And when we see their intrinsic value, then we will be much more likely to protect them.
So there's the Mpg doc. So a couple things that really stand out about that is when Joshua talks about the relationship that the ranch has and wants to have with the public as far as their research. And so I've, you know, when you look at their mission statement, they really talk about information sharing and education. And so this project that we're currently showing you guys has to do with that piece of their mission, where they're allowing us access to their research. And the even better part for our students is we're getting access to the scientists themselves. And so when you guys, if you get an opportunity, there's a couple different pieces that have already been put in place by Inspired Classroom, the Mountain Lion Challenge and the Golden Eagle Challenge, where you'll get access to their data, their research, and then also those scientists will do video chats with your students, which is, I've done it with my students and it's been pretty awesome. And hopefully next summer, we'll have things kind of back to in person again, and Inspired Classroom will be offering that opportunity to take some teachers to the ranch. And I strongly encourage any of you to use that opportunity, because for me, it was awesome, and just getting to see this place, and for our students to see how close it is for them and what's going on here in the state of Montana. So a couple of those resources that we were talking about, I've linked here. So the one that I just wanted to show quickly is the Mpg Research. So Joshua mentioned that their research is available. And so when you go to that link, you can see that there's 91 avian projects, 22 mammal project documents, and they're currently just being by the most recent. But when you click into these, there's tons of field notes, there's pictures, there's diagrams, all information created by scientists, and it's all just on their website. So as a science teacher, if you're looking even just to do some quick research about something locally, I strongly suggest just you taking a look at some of these resources and then providing them to your students. One of the big ones that we use when we're looking at the Mountain Lion Challenge are Joshua's winter mountain lion project reports, and he's been making these now for several years. And these have family trees in them, they have maps, they have all of, I mean, it's so much information. And my students, we've gone through them the last couple of years, and they really find it fascinating to learn about the stories of these mountain lions and to see the images that the ranch is able to capture. So definitely check out this tab if you're just looking for some localized quick research projects. And then there's also links on here for their staff, and they're very responsive, which is awesome. They also have some field notes. Their webcams is another great place to look. They actually have live cameras, and so your students can go see what's actually on their cameras at this time all over the ranch, and they show you where they're located. And then they have a great collection of photos and videos. They also have a Facebook page that's awesome for getting out new videos, and they post fun videos of animals on there. And then the last little thing here I wanted to share was the Inspired Classroom challenges that I mentioned. And so the kind of the current ones that they're doing with MPG involve the Golden Eagle Challenge. And so you can see they have things ranging everywhere from elementary aged all the way to high school. And so definitely a great opportunity for your students, no matter what age you teach. And these, you sign up with Inspired Classroom, and they give you a platform with all of the materials, and there's supplemental lessons and everything. And then the same thing down here with the Mountain Lion Challenge. And so again, you've got everything ranging from elementary to high school age. So it's a great opportunity to get your students experiencing wildlife and conservation of wildlife in Montana. And they also have some other projects that are pretty awesome as well. So definitely check out that link when you get a chance. And then I think we're up for Mike. So Mike, if you wouldn't mind just kind of giving yourself a little background for everybody and explaining some of your research that you work on at the ranch, that'd be awesome.
Yeah, sounds good. You can hear me?
Yep.
Thumbs up. Okay, cool. So I've looked at some of your backgrounds. I don't know if that's creepy or not, but I see a bear rug, and I see, at one point I saw an elk skull. And something I'm going to talk about a little bit is shooting sports. And a nice thing about talking about shooting sports to Montana teachers or anybody in Montana is most everybody has some experience with that. If this was Portland, I feel like maybe it would be an uncomfortable topic. So I'm just happy to be in this audience that I assume is very friendly. Okay, so I want to start out that we actually have an office in Missoula that's right next to Rock and Rudy's, and I see a teacher from Hellgate High School in there, so we're like neighbors. You're right across the street from me. So just to back up and focus on how I got to this position, I grew up in a hunting family. I was outdoors all the time, and when I got into high school, I started shooting some guns and the things that people do when they live in rural areas. And I'm from Washington originally, moved to Montana because I wanted to fly, fish, and hunt more. And I juggled majors for the first year. I studied biology, but there was something about biology that I just couldn't get on board with. It was, I think, all the memorization of facts. I felt like I wasn't really learning skills that I could directly put forth if I got a job. And I wanted to learn how to think more. And it seemed like I was learning those skills in my chemistry classes. So eventually I changed majors to environmental chemistry. So that had the strenuous classes in chemistry, but it also had a lot of geology and ecology and biology, and it was a really good balance. And I feel like that set me up to have a better career, because who thinks chemistry is hard? I do. It's tough. And when I changed majors to chemistry, there were only, I think, fewer than 20 people in my graduating class. And I think that alone can set people apart. And I want to go back to that PBS documentary that Bill just showed. So yesterday we had what's called an Ask Me Anything on Reddit. So a lot of different people can ask questions to Joshua and I, who maybe saw that documentary. So they're asking questions about, how do I get in a similar position? What's the best degree? And I answered that degree question, and it turned out to be the most popular question. People upvoted it like crazy. And my response was, I don't think the degree matters as much as the skills and experience you bring to the job. But I'm partial to chemistry and geology. I have a degree in both of those, because with those, you can ultimately land a pretty good, moderately to high paying job right after college. It's possible. And plus, you can have environmental focuses. You can throw in ecology classes, so that to get a job like Mpg Ranch doing ecology is still very possible. Okay, so I'll get back to the topic here of chemistry at Mpg Ranch. I started working for the general manager of Mpg Ranch before Mpg Ranch was started, just by working in his microbiology lab. And then, long story short, he was doing consulting work for the person who bought Mpg Ranch. I start working there, and I was doing a lot of research technician stuff, but there was this shooting range. Has anybody shot or did anybody shoot at Bitterroot Sporting Clays in the Bitterroot Valley? No. So it began in like 1996 and went to, I think, 2005. It was a really popular spot. It was down in the floodplain, so it was beautiful. There were these big groves of aspen, there were ponds, there were cottonwoods. And what shooters would do is they would walk a course, like a golf course, but with a shotgun. And the clay targets would fly through the air, and then the shooter, they'd try and take aim, and if they pulled the trigger at the right time and they were a good shot, the clay target would bust and then land on the soil. So there were like 20 to 24 of these target stations. And I had this degree in environmental chemistry, and obviously lead is a big problem at shooting ranges commonly. So I asked Philip Ramsey, the general manager, if he would mind if I just scoped it out. You know, took some soil samples to see what was going on, to see what type of lead contamination we had. And I had really never spent much time down there snooping around at these spots that were potentially contaminated. And it was very weird when I first went down there and started finding some certain spots that looked like mine slickens. They could be small, like as big as this room, or they could be maybe half an acre. And they were this orange color. Sometimes they were white. They looked like clay on top, not like clay soil so much. There's just something odd about it. And it smelled like sulfur. It just stunk, not like a fart, but like methane coming out of a wetland. So that raised a big red flag. And I had Ziploc bags, I had a trowel. So I just started taking some soil samples. And then I took them back to our little soils lab that we had in the house I was living at. And all it was this old workbench, not very nice, but we had a pH meter. And so I took some of the soil and I mixed it up with water, and then I let it sit for a little while to measure pH. And the reason I was measuring pH is because lead shot pellets that are coming out of shotguns are fairly immobile. They're not going to leach down into the groundwater and cause a big problem in most cases, unless there's a lot of them. But if the soils are acidic, that can happen. So I'm looking for acidic soils. So I mix up the soil and I take the pH, and in the samples, the pH was like 2 to 4. And if you're familiar with pH, that's really low. Soil should probably be about 5, 5.5 to 8. 2 to 4, that's like lemon juice. That's really acidic. That's what we see up, or what we would have seen around Anaconda or around the Clark Fork River prior to the remediation of all the mine waste up there. So that was really bad news. And we're like, oh, so is lead being mobilized? And I don't want to name any names, but I called the geosciences department at the university and I talked to somebody there. I'm like, hey, I've got these soils from the shooting range and the pH is really, really low. I'm kind of wondering if the trap targets are doing that, because I just called I called the manufacturer of the trap targets and I said, hey, what's going on? What's in these things? And he said there was sulfur. So then I talked to the geologist and he's like, no, that's not going on. You're not going to see that. So I thought, really? And so after that, I just started sending some of these samples out, some of the soil samples, and I found that there was indeed a lot of sulfur. And the deal that was going on is that there was elemental sulfur. And that's a very, very uncommon thing. So the geologist hadn't even encountered elemental sulfur ever in his work. But what happens is the bacteria in the soil, they can oxidize that. So like we oxidize the food we eat. Earlier, I was eating cashews. I'll eat a cashew. My body will oxidize it and I have a little bit of energy. Bacteria use the sulfur to do the same thing, to get some energy, but as a consequence, they produce sulfuric acid. So what was happening is for nearly 10 years at this shooting range, they were using biodegradable targets. They're biodegradable because the microbes degrade them, but the byproduct is sulfuric acid. So the sulfuric acid is just building in these places. And because not all of the targets were being oxidized at once, there's this constant push of acid over time that was creating these contaminated soils. And then I thought that would be, I'm going to speed it up here. I thought that would be a really good project to earn a master's degree studying. And so I ended up going back to the geology department where I was calling the professor who said that what I found wasn't in fact going on, and got a master's degree studying this. And that wrapped up in 2015. And I'm really happy to work with Inspired Classroom to get this forward, because ultimately it shows that if you're just kind of curious about what's going on, you can take some simple measurements like pH and maybe discover something that nobody's seen before. And this is something that I could not communicate very well to the shooting community. I pitched magazine articles to them just saying, hey, this is a problem. I never got any positive responses. So I think a lot of the shooting community doesn't realize this is even an issue. So I don't know if this lesson will really help that much, but it could help with that, to improve the cleanliness of shooting ranges. And also soil pH is just something that is fundamental in the biological and environmental sciences, because it controls nutrient cycling. It controls the composition of microbial communities. It's one of those master variables that an environmental scientist should really understand. And this lesson that everybody has created here should hopefully help students see that it's something that's very accessible and very useful to measure. Is there anything you'd like me to add, Bill?
No, I think that's good.
And if there are any questions, I could take those now or later, I suppose.
Yeah, does anybody have any questions right now before we kind of get going?
So I have a question. Can you hear me?
Yes.
I know that I'm in Billings, Montana. I live in Shepherd. I know there's a shooting range over here in Huntley where they shoot clay pigeons, I guess. And we are on the Eagle Bend subdivision where there's a lot of bald eagles. So I guess my question is then, is that still, I'm assuming that's still happening at all shooting ranges, and it is eventually going to hurt our eagles and our animals in the area. Is that kind of what you are saying you've put out to magazines and to the public?
Yeah, so there are a couple of things there. So what we found applies only to a certain type of biodegradable target, because the other option is petroleum pitch. There's actually a new target coming out that I shot, and on the box it says these targets will not acidify soil. And so my collaborators and I were like, yes, we did it. So I'm guessing that the trap range near where you live, they might be shooting something other than biodegradable targets. Just because I know that some range managers have seen that the machines that they use to throw targets, sometimes they get corroded if they use the biodegradable ones, but it depends. So they could be using petroleum pitch. Maybe that's not a problem. And as far as the bald eagle thing goes, the main threat of lead shot laying on the ground in a shooting range is that a bird, like any bird that has a gizzard that really requires the grinding of food, will pick it up. If they pick that up instead of a pebble, they can be poisoned. So that's not a big threat to a bald eagle unless something like a dove eats one of those pellets, gets poisoned, and then a bald eagle scavenges that dove. And in that PBS documentary, when I was speaking about lead poisoning in wildlife, the main source of that is from gut piles and carcasses that contain bullet fragments. So somebody shot the animal and lead was directly put into food that those scavengers would eat.
We have a couple of questions in the chat as well. Do you want to take a look at those, Mike?
Yeah.
Yeah. Tracy asks, have you been working on ways to mitigate the soil at that site? Or is it thought that nature will take its course over time?
Okay. Yeah, so start with that one. We have tried to mitigate the soil, and that's actually part of this lesson, so I won't speak too much into that. But briefly, these biodegradable targets, they have two main ingredients. One is sulfur, that produces acid. And the engineers of these targets knew that acid would be produced, so they added calcium carbonate. Those two ingredients can be used in gardening to raise and lower the pH. Like if you have blueberries, you want somewhat acidic soils. The problem was that there was twice as much sulfur as what the calcium carbonate can neutralize. So the solution to this problem is to add more calcium carbonate to the soil. A challenge is that the sulfur alone isn't necessarily bad. What's bad is the byproduct of bacteria oxidizing it, that's sulfuric acid. So that means that over time, acid can be produced. And if you put a lot of calcium carbonate on top of that sulfur to begin with, it's possible that that calcium carbonate could raise the pH too high before the sulfur acidifies the soil. That's a lot of up and down, so I hope that made sense. So another question is, does that impact the groundwater and its quality? I don't really think so. We found that there were some areas where lead did seem to be somewhat mobilized into the soil, but the concentrations were still very low, a lot lower than what you would normally see at a shooting range, because the nature of this shooting range was such that lead was shot in very dispersed areas, as opposed to a rifle range where bullets are being shot into a single berm. So if there's a lot of lead in a single berm, that can lead to issues if it's not remediated over time. But at Mpg Ranch, the lead was very dispersed. It's possible that that sulfur in the form of sulfate was infiltrating into the groundwater, and without oxygen in the groundwater, it could have been reduced to hydrogen sulfide. That's the rotten egg smell. That's not necessarily good or bad. And then, am I willing to talk to classes? Yes, I actually do that frequently. Not as much on this issue as much as lead poisoning in wildlife, lead poisoning in eagles, but yeah, I can certainly blend those two, and I think both are complementary. And then I know the next question is, I know some people who shoot biodegradable clay targets into a body of water. Does this do the same thing to acidity levels? I would say no, because there's going to be far less oxygen available in water for bacteria to use to oxidize that sulfur to sulfuric acid. In some cases, if there's no oxygen, that elemental sulfur could be reduced to hydrogen sulfide, which is arguably not a big deal. So I don't think there's a problem with acidity, but it's a problem with waste, I think, because those targets are probably going to lay there for quite a while. And I don't think that's good for shooters to be leaving waste all over the place. It's not good for the environment either, obviously. Oh, and so I want to go back to how to mitigate the soil. You can add more calcium carbonate, also called limestone. Honestly, over time, I think nature will take its course, because with more rainfall, that's going to wash the sulfuric acid away. And then the elemental sulfur sitting on top of the soil will continue to oxidize and then continue to wash away. So there might be pockets that have really high acidity that'll take a really, really long time to adjust. But I don't know how long it would take, decades, century. I think it really depends on the amount of rainfall and temperature. Thanks.
Thanks, Mike. So these are the two kind of research articles that I used when piecing together some of the readings for the high school students. So these are both publications that Mike and some of his fellow researchers had published about these topics. And so throughout the lesson, I integrated pieces of these, like the abstract, some of the data, and those would be a little more pertinent, I would say, with the older students. If you're going to do this with younger students, you'd be looking more at just the actual experiment part of them collecting soil samples. So if we look kind of ahead at the lesson plan, whenever I create lessons, there's kind of a progression that I have and some main kind of things that I want to make sure I follow through with. And so the first one is I always want to make sure that my lessons are relevant. And as you can see, this is happening here in Montana. It's currently happening. So I think it's really easy to get buy-in with your students when you're showing them something that is local and current. I always also want to make sure that I'm incorporating as many standards and as many disciplines as I possibly can. This one really is going to focus heavily on math and science, but also obviously ELA with the reading, and especially with those juniors and seniors that are maybe taking environmental science or chemistry. There's some upper reading when they're reading those research papers that Mike was working on. Obviously current standards, and so I try to always make sure that I have that common core, the math and the ELA, the new science standards, and so we're going to really focus on the science practices with this versus necessarily the content, and then also making sure to always integrate Indian Ed for All when you can. And I've been able to add a nice little clip in here and a couple different things to talk about of ways you could extend this lesson and looking at traditional ways of mitigating soil and conservation. And then finally, my big thing when I'm creating lessons is I am always thinking about who's doing the thinking and talking. And it's always the irony, because when we do these trainings, I end up doing most of the talking, but in our classrooms, we really want to make sure that our students are the main lift, they're the main driving force of what's going on. So kind of the progression that I created for this, and like I said, this is still kind of a work in progress, and we're not going to look at all of these pieces, but you can see I've kind of followed the 5E model, where you're going to start by engaging your students kind of in 3 little components. One is what really soil is, what pH is, and then the problem that Mike was seeing. And so they would be introduced to that problem through some videos with Mike and also some of the readings. We get into the explore piece. We're going to look at some of the experiments that Mike was just talking about, but also the students are going to do their own experiment where they're going to take soil samples and calculate the pH of those. And there's going to be a series of videos. We'll see a little clip of it today, but there'll be a series of videos that would be in the Inspired Classroom setup so that you'd be able to either watch those yourself and then just show your students, or have your students actually watch them and then conduct it. When we get into the explain piece, you'd be looking at what Mike actually found out during his research, a little bit about how we can mathematically solve to mitigate soil. Like, so what is the equation that we could come up with how much limestone to add based on the pH and the amount of soil we have. And then also your students would have their own data that they would be able to hopefully start analyzing and explaining there. And then one of the big extensions that, like I said, I mentioned a little bit about the traditional soil mitigation, or really traditional conservation, and looking at, there's some clips of tribe in California, and then also with the Blackfeet Reservation and the Blackfeet tribe and how they've traditionally mitigated soils. And then also extending a little further and looking at what a chemist actually is. Because like I said, one of the things we wanted to do was kind of break down that stereotype for our students that you can be a chemistry working out in the wild. And then for high school students, the evaluation piece would be creating a lab report based on their experiment. And I've created kind of a template that follows along with the next generation science standards to do that. So we're going to kind of go through just a little bit of each of these as long as time allows. And then a lot of these resources, like I said, are still being worked out. Several of them, though, are in that share folder. And so you can kind of look at what they might look at or look like, in there. So the first little bit here is that engage piece. And so we're going to look at pH. And so what we're going to do, this is an example of one of the handouts on the side here. We're going to break into some groups. and I think Allie's going to have to help me do this piece. I don't know how many individuals we have in here, but the idea is there's 4 different pH handouts. And so what I'd really like everybody to do is look at just one of the pH handouts. And then as a group kind of work on summarizing what that document teaches us about pH. The big idea is we want to look at it like we know nothing about pH, because many of our students might have heard of pH, but they'll have very limited understanding of pH. And so when you're doing this, please kind of think in that terms. And so there's a link to the Drive folder that should have what is pH handout 1, 2, 3, 4. Allie, is there a way to make 4 groups of participants and then have each group have a different handout?
Absolutely. So I'm going to go ahead and create 4 breakout rooms. I'll do that once we've given all the instructions so everybody sort of knows what to do. You'll be assigned to a breakout room. It'll pop up on your screen and it'll say join breakout room. So click that. And then it'll say breakout room 1, 2, 3, and 4. So let's just go ahead and have breakout room 1 is going to look at handout 1, breakout 2, handout 2. Does that work for everybody?
So yeah, so when you do this, the big idea is we're going to only be in our breakout rooms for probably like 10 minutes at the most. And so what we want to do is look at our handout through the eyes of a student, kind of summarize any of the big ideas that we're getting from that document or anything that we're learning about pH. Because right, the idea is we're introducing our students to pH with these handouts. And then we will come back together and we'll just have 1 person or 2 people from each group kind of share to the whole kind of what they were learning or what they were figuring out from their handout. And then if you guys notice anything on the handouts or anything like that, again, this is a work in progress. So please provide some feedback for us.
Okay, are you ready for me to?
Yeah, I think so.
Everybody in their breakout room? All right, I'm opening the rooms. All right, here's one breakout. One breakout group is back. Here they come.
Cause it to be more basic. It's generally about an 8 versus the other samples are below 7.
I only caught part of that.
Okay,
Screens
don't
are-
worry about it. Back anyway.
I think here in a second we should all be back. Is that right, Allie?
Yep, we should all be coming back.
Okay, so what we'll do then is we'll start with someone from group number 1. And so kind of what I was telling my group was just to discuss a little bit about what your handout showed, since no one else was really looking at yours, and then kind of your big takeaways, especially if you were a student learning about pH for the first time. So does someone from group number 1 want to share what they talked about?
I can share.
Thank you.
Okay, so in handout number 1, it is actually that the pH scale that was shown earlier to the whole group. And we, as far as discussion goes, I guess one thing that I said, we didn't have a whole lot of conversation, is me in teaching 5th and 6th grade science. My students would say, well, a lot of the foods that we eat or consume, things that we consume, are going to be on the lower end of the scale. So they're going to be more acidic.
Mm-hmm.
Somebody else want to step in? Mike, do you want to step in?
You're also talking about the water samples that you do for with your class. So I thought I really got a lot of information out of that because I have 5th graders. So I really thought that was valuable for me. So.
Perfect. Someone from group number 2 want to talk a little bit about their handout and some of the stuff they discussed?
Sure. So in worksheet number 2 or handout number 2, they talked about what a pH scale was, which was pretty fascinating. You know, I haven't taken chemistry in a long time, but I do teach high school math. And this is one of the applications we always seem to talk about is in terms of logarithmic scale. You know, the pH is a logarithmic scale. But I actually sort of forgot what the pH actually stood for. So it turns out it stands for the ratio of how many hydrogen atoms are in the comparative solutions. So we talked about some different ways we can sort of expand it across grade levels. You know, in high school, a lot of times you'll say, well, you know, if it's 7's you're neutral and 5 is more acidic, it's only, you know, on the pH scale 2 times as much. But what does that really mean? You know, in terms of logarithmic scale, it's 100 times as much. We talked about some of the younger kids. Well, you know, if you're in, you know, 2nd, 3rd grade, that's a very abstract idea. You know, 100 times as large is sort of difficult to understand. So they said, well, could we start modeling it and sort of saying just how much is 100 to 1 and sort of put that into a more concrete idea. So different ways to differentiate against grade levels.
Awesome. Thank you for sharing that. Handout number 3.
I will go on that one. Also a high school math teacher. And so jumps right in with a formula, which is a logarithmic formula. And again, there's a table there. So I think you could use it as an introduction to logarithms for students who don't understand what a logarithmic scale is. So it was nice to be able to see that this can be applied in math classes, not just a science class, that there's definitely that connection between the two of those. And kind of same thing, you can model it with graph, and before they jump into a calculator that's just going to calculate it for them.
Awesome. And then finally, group number 4. Carolyn.
Sorry, I was on mute. Mute, and so you missed all the great stuff I was going to say. So I'll restart. This is take 2. So I'll report about what handout 4 is, and I'm a great one to do this because I'm like at a level of what a student is as far as knowledge of pH levels. I like this example because, or handout, because it talks about like extreme acid, compares it to foods that kids are familiar with, like lemon, tomatoes, carrots. And I know kids will really like that, to know that saliva is neutral. Then it moves on to more alkaline, such as, you know, seawater down to ammonia. And at the bottom of the handout, it talks about the 3 major factors that cause the soil to become more acidic. And the first one's rainwater, then carbon dioxide from decaying plants. And then 3 was from decaying matter, which I think the students would really like to have more discussion about those 3 things. So for me, I really like the handout. I think it explained a lot for it coming from a student. I'll say, consider myself a student's eyes. And like I said, with our group, I'm more interested, or I did a little bit of research trying to change the color of my flowers. So I'm interested in this. So thank you.
Thank you. So the idea here is if your students had no understanding, obviously, of pH, you could give them each different handouts. Handout number 1 is probably the simplest handout. And so you could also, depending on your groupings of students, you could have students that might have stronger math backgrounds look at different handouts. All 4 of the handouts are currently available in the Google Drive in the shared folder. And obviously, there might be some changes along the way as we go, because this is kind of our first trial with some of this. So that would be one example of how we would do the engage piece. Like I said, there was kind of 3 components to the engage. There was the intro to soil, intro to pH, and then the problem, which was what Mike would be discussing as far as the shooting range. Before we move on out of the engage piece, does anybody have any questions or comments for me or for Mike or the Inspired Classroom group? Okay. And if something pops up, Allie will let me know. So the next little piece is looking at the experiment. And so again, for those upper level students, they'd be reading a little bit about what Mike actually did out of his research papers. But then there's also going to be the component where the students will conduct their own soil research. And this is the piece where we would have videos of Mike conducting the soil sample and how to actually take a soil sample, how to randomize it, how to conduct the pH of that just using litmus paper. So you can use probes if you have them. If you don't, literally all you would need is just a little bit of litmus paper. Do you have access to pH test strips? Jana, I do have some pH test strips in my classroom, and I will be also getting more this year because we tend to go through a lot. So yeah, I can get you pH test strips. Jana and I work at the same school, so good to know. Awesome. So anyway, so I was going to share, this is kind of just the intro to what we've got going on so far. And again, like I said, there's going to be a lot more clips for the experiment piece. There'll be a protocol, but the idea is that your students are going to be looking at soil samples, and they're going to be doing it from 2 different locations at least, or you could do it at the same location and have them compare it during different seasons. The big thing though with doing soil, and Mike kind of mentioned this, is you're probably not going to see a lot of variety. So really it's not necessarily about seeing, you know, really acidic soil, because chances are you're not going to find that and on your school grounds or at their homes. But it could be useful for them to maybe, even if they're doing this at home because they're remote learning, they could take soil samples if they have a garden area and compare that to their grass, or if they know that they've been using a lot of fertilizer on their grass, compare that to like a natural field or natural area. So there is some areas for them to do the experiment and kind of maybe see fluctuation, but the real idea is for them to, you know, actually get out there and collect sample and see how to take pH more so than hopefully, you know, finding something big, if that kind of makes sense. Let me see this one more question. pH testing is designed. Oh yeah, there you go. Thanks, Allie. So here we go. Whoops, I lost Mike.
This range was in operation from about 1996 to 2006, and then it was retired. No more people were shooting down here, and Mpg was bought by the current owner in 2009. And a few years after that, I started looking at the contamination down here because I had a chemistry degree, and I thought it would be a good fit to study a shooting range because shooting ranges tend to have a lot of lead contamination. And when I was down here, I found that the contamination was mainly from the trap and skeet targets. So what the problem is the trap and skeet targets, the little discs that fly through the air and get shot by the shooters, have a certain chemistry in them that can lead to soil acidification. I have several tubes, all have been labeled beforehand, and now what I'm going to do is I have the soil, and I'm going to show you how to sieve it if you want a standardized grain size, and then after that I'll show you that you can kind of just go around that by yourself. So I'm going to pour this into the sieve, and I have it sitting on just 2 regular sheets of paper. And now all the big particles, like these rocks, are not going to go into the tube. Now I take the tube, I can take the soil, and I can pour it in.
So that last little bit there is a good example of kind of what the how-to videos will look like. And so you can see there Mike was showing how to prepare the soil in order to test the pH. The other sections of the video will show how to actually collect the sample. The best part about this is it takes very limited materials. So if your students are at home on their own, as long as they can get pH strips into them, they would be able to do this. I mean, we used baggies and test tubes, but you could use really any container, need some water to make the solution, and then really just the pH strips. So the big piece of this, like I said, will be the students doing this experiment and checking the pH of soil in their area. And so they could do that in groups, they could do it by themselves. There's a lot of variety or options to that. Mike, do you want to add anything to the experiment piece that I didn't talk about?
No, I think you did a good job.
Okay, any questions?
Did you see the one from Kathleen? She said that she found some really cheap pH strips at Lowe's, Home Depot, and on Amazon. Would that suffice?
Yeah, it would. I mean, yeah, they're pretty common supplies, so you can get them just about anywhere. The big thing is though, if you're going to send them with students and just send the strips, they need to have the ability to read the strips. So usually the test tube that the strips come in, or the packaging, has the different soil pHs on it. So for people that are familiar with the pH strips, they've seen that. But they would need that scale for their house if they were going to be sent home, just to know that if you're doing it remotely. So anyway, so yeah.
Is that something that you could take a picture of and then post it in like your Google Classroom or
you could. You could. It wouldn't probably be quite as accurate just because the coloring on a computer screen might be slightly off.
Sure.
But you could definitely do that if you needed to. So
okay.
So the idea though is to get your students to actually collect their own soil samples and then to do the pH of them. And like I said, unfortunately, they're not going to most likely find big swings in areas. I know at the school that I work at, we used to burn coal for a really long time. So I am planning on this next year, seeing if there's anything going on with the soil back where the coal was, just because I think it'd be fascinating. Or maybe Jana can do it with her younger students and we can compare notes. But I think that would be something cool. Or like gardens or different places like that that you might find on campus. Or next to bodies of water, if you have a riparian area that you can get your students to, maybe you'll see something different right next to like a creek or right after runoff than you would at different times.
Bill,
yeah.
You could also do some collaborations within schools. Maybe ask Anaconda to do some samples for you, Gardner, and get some variations within the state and see what the samples would vary.
Mike, that's a great idea. And that's one of the things that the Inspired Classroom, because it's all digital, and if you'll sign up for this lesson kind of through their site, if they have different teachers in different areas, that would be a cool piece that they could add into that, where you could just dump your data.
If they want to do it in Anaconda, they should probably wear one of these.
As they're digging up the soil.
I mean that half seriously, actually. Yeah.
But yeah, so I think that, yeah, Mike brings up a great point, of the collaboration piece of this. And that's been one of the nice things about the Inspired Classroom projects, like with the mountain lions and things, is the ability to send those questions in and collaborate and get data all kind of grouped together. So then the next little piece.
We have one more question there I saw in the chat box that just came through. Sorry about that, Bill.
What was it?
What is the soil to water ratio that you use to prepare your soil solutions and make them comparable?
Mike, do you want to touch on that? Because I think I remember what you put in your test tube, but I'll let you, if you remember.
Yeah. To be honest, I don't remember. Before we shot that video, I looked at the papers that we published and I tried to replicate that. I think in the test tube, ideally what you would probably do is do 10 grams of soil. So you weigh that and then add something like 20 milliliters of water, mix it, wait 30 minutes, mix it again, and then take the pH. I discussed that a little bit in the video, but what I would recommend is whatever is done for one sample be replicated across all samples so they are comparable.
And I think when we did it in the field, because we didn't have a scale with us, we looked at the same volume in the test tube.
Yeah, we did that.
After you sieved it, you then put like 10 milliliters of volume in the bottom of that tube because it had markings. But like Mike said, as long as you're consistent and it makes a solution, you would be able to test it. So then the next kind of little section, let's see, is there another question?
Is distilled water needed? That's best for the experiment, or for the survey we did. We did not use distilled water just because I felt that I wanted it to be as accessible to students as possible. And we measured pH of different things, soil, lemon juice, bird poop, and we took the pH of the tap water too, just for a comparison. So it wasn't ideal. Distilled water would be best, but I think it's okay as long as you understand where you're starting at with that tap water.
Yeah, I think the idea is as long as you're using the same water for all of the experiments, it's kind of irrelevant, right, Mike?
Yeah, I think for high school, yes. Yeah, I would never suggest that for any real science, though.
You mean published science?
Published science, yeah, something like that, or even something in an undergraduate class, because ultimately tap water can have a bunch of ions in it that can influence the pH. So you want to start with something that's as blank a slate as possible. But I think for this lesson, tap water is absolutely fine.
Perfect. So the next little section we're going to look at has to do with, so there's three pieces that I had, like I said, in the explain piece. One would be your students looking at their actual findings and what they found out from their experiment. One is a little bit of a math exercise about mitigation of soil using some of Mike's data, and then also some of his findings. And so we're not going to do this piece together, but this is an example of what your students would be doing with some of Mike's data. So he provided some soil data that's specific to his research. And when you look in the shared file, there's a file that says Mpg Ranch soil data. And the idea would be to give your students the blank data table and have them construct a graph, maybe more than one graph. Maybe it's a graph with multiple components on it. Typically in class, I would do this with graphing software, but you could do it even by hand. It's really up to you and how you want to do it with your students. But the idea is they're taking raw data that's just in a data table. I guess it's not technically raw data, but data from a data table, and creating a graph on their own. And then having them compare their graphs. So there's not like, you're not just explaining, hey, this needs to be the x-axis, this needs to be the y-axis, but it gives them that freedom of looking at the data. And when you look at the data table, let's see if I can find it really quickly just to show you guys. I can find. So this is what that soil data looks like. And you can see that there's a lot of options then to make a graph out of it. So the data that he provided has the sample numbers, the pH of that sample, what percentage of cover trap targets have their, what percentage of vegetation, and then calcium and sulfate concentrations. So your students could create all sorts of graphs using this. It's just a data table. And so the idea is to help them understand, you know, kind of best practices in graph building and just to practice building graphs. And so that's the first little piece of the engage section. Let's see if I can get back to my presentation here. And then the next little piece, and we're gonna try to do this one. We're gonna use the Lime requirement data set, and we don't need to use a breakout room, I don't think. I just want you guys, if you can, to open up. So just like you opened up what is pH, you're gonna open up the one that's labeled Lime requirement, this doc right here. And we're gonna just take a quick look at that, and we'll kind of talk and walk through how I would do this with an upper division science class in the high school, like chemistry or environmental science. So if everybody could open that document.
So it looks like there are two documents, but you're after the Word file.
Yes, yeah, not the Excel file, but the Word file. So all this document has on it is a graph, and then you can see down below it's got the data points that are on the graph. In order to show a linear relationship, just because I feel like that's the easiest way to do it with high school students, I made sure that the origin was at 0 and 0. And so the idea would be with your students to give them this handout, so ideally print it off, and have them come up with a line of best fit and the equation for that line. So there's obviously going to be some varying answers to this. But so if we think about creating that line of best fit, where we'd want to draw that line, and then we're looking, obviously, I put in the presentation, the easiest way would be to have them, you know, think about putting it in slope intercept form, where the y-axis is representing the Lime requirement. And then obviously the x-axis is representing pH. So you'd want your students to calculate the slope of the line, and then where that line is crossing the y-intercept. So where it's crossing the y-axis. So if you guys are looking at that document, and you might not have a straight edge with you, but you might have a piece of paper or a pencil or something, kind of rough in where you think that line would go, and try to create kind of to your, you know, rough ability just on the spot, what you think that equation might be. And then I'll have a few of you share your equations just in the chat if you don't mind. And then we can kind of go from there to the next little part of how to use that equation with your students. So I'll give you guys just a little bit of time on this document, and I can leave this page even up if you're not on it, and then try to create an equation that, like I said, it doesn't have to be perfect. Take into consideration that these 2 points down here are at 0. There's no Lime requirement. So I wouldn't necessarily start the line over here and go through the points, but maybe I would, I don't know. It's up to you guys. That's the beauty of it, right? Let your students kind of figure it out. And then if you guys get equations, just throw them in the chat, and then we can look through them. But I'll give you guys about 5 minutes or so, even if it's just the slope. So as you guys are kind of working on this, and I'm seeing a few equations pop up, a couple things to think about with students is you could just give them the data table and see if they could figure out using multiple points off of that, the line of best fit, which I feel like would be a little bit trickier. I personally would just give them that graph and do kind of what you guys are doing, and roughing in that line. The big thing that you want to make sure that you emphasize with your students is that there's going to be units to some of these numbers, because then they can cancel when you're doing calculations later. So as I mentioned in the page here, that your y-axis is representing lime requirement. And if we look back at the data table or the graph, the lime requirement is calculated in tons. So it's that many tons of lime per 1,000 tons of soil. And then the x-axis is your pH. So when we look at slope, slope is change of y over change of x. So really what we're looking at is the change in the lime over the change in pH. So your slopes units would be that lime requirement divided by pH. And that allows us then to manipulate the equation, to use it to solve problems. So what we're kind of getting at is we could give them that graph, have them come up with their own equation, as many of you did, and then use that equation to solve problems. Granted, everybody's going to probably have slightly different equations. I saw that first one on there was a slope of -7.5. And so what is that meaning? That slope is decreasing and it's change of y, so it's that difference in the amount of lime versus the difference in pH, and then the y-intercept being 40. So if we come up with an equation, right, then later we found this little tidbit, or Mike did, whoops, of how many tons, so there's 1,000 tons of soil, how much does that actually equal? And obviously this is from one resource and it's probably varies a little bit, but roughly if you have an acre of soil that's 6 to 7 inches deep, you have about 1,000 tons of soil. So when we're talking about how many tons of lime is going to be needed to mitigate an area, it's looking at, 1 ton or how many tons per 1,000 tons of soil. So for an acre, about 6 to 7 inches deep. So this allows us to create some math problems. And so I've got one example of what the math problem might look like. And then in the lesson, there'll be kind of a little math exercise where they'll take their line of best fit and do that. So if you have a line of best fit, use that. If not, jump into the chat and just use one of the ones that someone added. Let's see if we got any more. What grade level do you usually show this graph to? Do you ever use nonlinear graphs? Do you cover correlation at all? Those are really good questions. I would use this graph obviously with high school students, but you could just show that graph and see the trend with any age of student. As far as creating an equation, obviously they're gonna have to have some algebra background. And so as far as nonlinear graphs, I probably wouldn't with my students per se, but I know that would definitely be appropriate with people or students with the appropriate math background. So I think there's definitely that opportunity to do that. So if we look at like a practice problem, here might be an example of one. So using kind of and I'll show you the steps that I would take to do this. But using the equation you calculated, we should be able to figure out roughly how many tons of lime we would need to mitigate that soil. So if we had soil that we only want to mitigate the top 3 inches. So we just mentioned that 1,000 tons of soil is about 6 inches deep, 6 to 7 inches deep in 1 acre. So let's say we have a 4.3 acre plot, we got a pH range, we want to try to mitigate that. How can we solve that problem? So if you've got an equation, you can try it out. Here's the steps I took, and then we can kind of go from there. So the first step, you'd want your students to calculate how many tons of soil need to be mitigated. And as I mentioned, we have 4.3 acres, 3 inches deep. So how many tons is that? And the conversion we're going to use is that 1,000 tons is 1 acre at 6 inches deep. So if you get an answer to step 1 and feel like sharing it, just throw it in the chat box. And then I can share mine as well. This is also a good opportunity for science and math teachers to really help our students with dimensional analysis too, and how to calculate and convert units, because we're taking things that are a little more abstract to them, like 3 inches of soil, and converting it now into tons. But I think that definitely at the high school level, this is a skill that they need to be able to accomplish. So we got our first answer up on the chat. Michael said around 2,150 tons of soil. Michael, would you mind sharing real quick how you did that dimensional analysis, or what your equation was?
I'm going to go ahead and just sort of vocalize instead of typing.
What was that, Michael? Sorry, I couldn't hear you.
Can I vocalize instead of typing? Can you guys hear me?
Yeah, please.
Okay. So if I was thinking about trying to explain this to some of the students, I would first start with the 6-inch depth and just go assuming a 6-inch depth. So if 1 acre was 1,000 tons and we need a 4.3 acre plot, we take our 1,000 tons, times it by our acreage, which is 4.3. So we have about 4,300 tons. But then if we're looking at the ratio, 3 inches is sort of nice. We can sort of think that's half of the depth that we need. So we can take our 4,300 tons of soil and then, or lime, I should say, and then take half of that to get 2,150 tons. If it's a different inch, you can go that ratio. You can do, 3/6, 2/6, 1/6, whatever ratio you want to go with.
Awesome. Yeah, that's what I got as well, right? So we got about 2,150 tons of soil need to be mitigated. And then after we get that number, now we need to figure out how much lime it takes to mitigate that much soil at that pH. So this is where our equation comes into play. And each of us have slightly different equations. But remember, we're trying to solve for how many tons of lime. So that's luckily the way we set up our equation, y equals mx plus b. Y is equal to that number of tons. And so we just need to plug in numbers for the mx and the b. And so if you created an equation, you can use your slope, whatever slope you got, and then your b value should be your y-intercept, and then just plug in that 3.9 pH into the x value. So once someone gets a rough answer maybe to step number 2, so again, you're just using your equation you just created, or one from the chat if you'd like, to solve for y using a pH of 3.9. So I used that that first equation that Michael put up there of negative 7.5x plus 40. And if you plug in the 3.9 into x, I got 10.75 tons per 1,000 tons of soil is what I solved for y. Let's see if that's, okay, I got the same. So then once you have how many tons you need per 1,000 tons, then you use the numbers you calculated to figure out how many tons of lime are needed. And so for this, I just used dimensional analysis where I start with how many tons of soil need to be mitigated, 2,150. I multiply that by how many tons of lime I need, which was 10.75. And we get that we need 23,000 tons of lime to mitigate that much soil. So you can see that it's definitely geared more, like these type of problems would definitely be geared more towards high school students, and but it is a good practice, like I said, with dimensional analysis on that end. Anybody have any quick questions about some of the math stuff before we kind of jump ahead real quick, because we're running out of time? Before we run out of time entirely, I did want to show this short clip and then talk a little bit about how you could use this as an extension to this lesson with talking about traditional soil mitigation. So I'm going to play this real quick, and then we'll have a little brief discussion, and then I'll let you guys go.
Carrying fire, the Piikani way. The Piikani people, also called the Blackfeet, have lived in the northern Great Plains of the United States for hundreds and hundreds of years. In the time before railroads, before European American settlement, and before reservations, they were a migratory people. Every year, they moved from one place to another so they could hunt the buffalo and harvest other foods and medicines. As the Piikani traveled, they took fire with them. How did they do that, and why? Listen to the stories of Marvin Weatherwax, an elder of the Piikani people. He will explain about the Piikani way to carry fire throughout the year as the people followed the buffalo.
Fire is, very important to us. It was very important to us in many areas. One of the most important areas was conservation. Piikani people were very, very conscious of making sure that when they left the area, that it was clean and that it was going to come back just the way they found it. So when they left camp, they would burn the area so that the things they left there was all burned. Everything was burned, the whole grounds and all. And what that did was it left it to renew, and it would grow back and renew. The fire was very important. And another aspect was that was how they built their pharmacies. After a fire, the first thing that comes up is the weeds. Many of them are the medicines that we use for various ailments and the things that we need. We'll make a fire, deliberately burn the area where we know that certain plants are. It'll burn them down, and then they'll grow back.
So one of the ways that I would use this in my classroom is a way to introduce essential understanding number 3 and also lead a discussion. There's also another video, like I mentioned earlier, that's going to be part of this that comes from a tribe in California and how they are using fire there as well. But the idea is to really introduce our students to some of these essential understandings. And this one looks at how culture still persists today. And I think that video really does a good job of explaining, and there's a lot more to the video than what we showed, but explaining how conservation is important and how they looked at the conservation of their soil as well. So that would be a part of the extension piece. And then there's a few other extensions, chemistry job description with some links. We're not gonna have time, obviously, to get through everything as we're running out of time. There is a folder with some of this stuff built in there. And if you get a chance, like the lab report handout I have put in there, make copies of everything. And then we will be obviously having this up hopefully soon with Inspired Classroom. So look through your emails, and if you get a chance, sign up for the lesson, and you should get all that material. So thanks everybody for sticking with us. And yeah, so thank you guys.